Good morning, good afternoon, good evening, everybody. So I'm pleased to present today at Grey Hat on attacking networks with pCraft. So pCraft is a tool that I wrote, which doesn't do like OpenVAS and Nessus or those tools that have a script to just run attacks against a particular vulnerability on network, but more a way to craft an attack and craft a pCAP out of that attack in order to do some testing of your SIEMs, your IDSs, and tools that you're using to understand their limits, their extent, and make sure that you are doing a good job with this particular type of attack. So I'm Sebastien Tricaud. I work at Devo as Director of Security Engineering. And you can find me on Twitter at Tricaud. And please feel free to interact with me. I'm more than happy to learn from your experience and the things that you get to say around these kind of things. And anything that can help me to just make the tool better is more than welcome. So I'm also helping a project called MISP, which is a platform very popular to share and enrich threat intel. As part of this, I am the lead developer of a database called SightingDB, which keeps track of indicators that people are sharing in the threat intelligence world where you can track and keep count of how many times you've seen something, since when, and enrich your data this way. Also, I'm the lead developer of a tool called FOP, which allows to parse URLs and get things like domain, TLDs at scale. So it's a C library with Python bindings, things I like to write, just like pCraft, as you will see. I'm in the Honeynet project. I was the CTO of the Honeynet project for a while, and now I'm a board member. We still develop a lot of cool tools, so I encourage you to have a look at what we do. And in the past, I had the opportunity to work on many open source projects. The two most notable are Linux Spam and Prelude IDS. So this is a picture that I'm pretty sure that you have seen in a lot of security related presentations. So it's a good way to explain how an attack works, the steps, and what people actually are doing. In this case, this is about a phishing attack where the attacker is sending a malicious link to the victim, and having a web page that looks like the bank of the victim, where the victim will click on the link, believe it's a legitimate web page, and then enter their credentials. When the victim enters the credential, then the attacker reuses those credentials against the legitimate website and get the money out. So, I mean, it's a very simplistic way, of course. Even though it's still efficient, there's more and more two-factor authentication here that can help to improve this posture. However, it's just to get an idea of an attack scenario. And we want to understand more than just that scenario here. So the thing is, those diagrams that we see in slides over and over, they are insufficient. So they just summarize an attack for the general public. I mean, I'd be happy to walk my mom through this slide and have her understand how the phishing would work. But you are not the general public. I mean, you want to scratch the surface. You want to understand more about that attack, and you really want to understand the details about that particular attack. And one way that people do in that case is using pCAP, which is the packet capture format that a lot of people are using with tools like Wireshark and such. So you can Google for this, DuckDuckGo this, or you can ask your friends if they have a pCAP on this attack, or something like this, and then have a better understanding of this. Also, in the Honeynet project, we've been having a lot of challenges, and we've had pCAP, other challenges that you can use. So the real question here is, would you have detected this type of attack with your SIEM or your IDS? And the question is not that obvious. Usually, you know what? Usually not. A phishing attack of an unknown website is something that's unlikely to be discovered easily by an IDS. However, you want to make sure of it, or you want to maybe improve your signatures. You want to understand more about what kind of footprint that would be into your SIEM, and try out the adversary simulation here to see what kind of logs would have been written to your sim if such an attack would have appeared in your network. And it helps you to be more prepared. So what we do is that we want to create a PCAP about that phishing attack. So first of all, the victim would click on the link, and clicking on the link means what? Means there is a DNS request that be made to get the IP address of the host, and then would start an HTTP session. So I mean, it'd be the same with the HTTPS session. You would just add the TLS headers here. But to simplify here, we have an HTTP session where we first send the TCP three-way handshake, and then we send the HTTP request. We get the HTTP response, and then we just finalize the job. So when you've terminated that job, that means that you send just a fin flag if the connection is terminated. So pCraft was built to do this. pCraft was built to have you describe the steps that you want to go through in order to create a PCAP of the attack to help and share the attack scenario and also test your various tools with that attack. That's what it was meant for. So the installation is, it would require to have three tools here for this tutorial. One is pCraft, coming from GitHub, Devo Inc., pCraft. The other is TCP replay and Circala in order to test out the IDS and check if we're detecting something here. Another way is to pull the Docker image that I built that just contains everything that you will need for this exercise. So you do a Docker pull on the SigningDB pCraft, and then you run the pCraft image here as a daemon, and you can start to play with the tool. So let's create the first pCAP. So basically, when you have done the Docker image, you are here in the build directory. So you can go to your home builder pCraft, and you have pCrafter installed here. This is the Python bindings for the AMI language, which is a language that helps you to describe the attack. So let's create the first pCAP here. This is the AMI language I was just telling you about, where you have to set the version to 1. So we set the version to 1 here because I want to make sure that tomorrow when I improve the language and I learn more about what people are doing with this, and I want to integrate the good ideas into the language, I want to be backward compatible. So starting with version 1, you have to set the version 1. Then we just tell the action we want to run. So the DNS request action here is just a name you want to give, so it's nothing in particular here. And then we give a domain variable. We set that to greyhat.co, and we tell the execution that we want to make by doing the exec DNS connection. So let's do this. Let's do a dns.ami. So AMI version 1. So if you don't do this, it will just not work and run the AMI. So AMI version 2.1, and then I'm calling that action. This is my action, and you start the block where you tell which plugin from pCraft you want to execute. So I will give you an overview of the different plugins later. But for now, you have to know that the DNS connection plugin is the one that's going to create a DNS connection. And then I set a variable for the domain to greyhat.co. So in this case, the variable is part of the scope of this block, so I can put it up here or under the exec. So it's just a matter of taste. I did it like this, but you can do it in any way. So now that you have done that you have described the action that you want to run, you just run pCraft on dns.ami, and you create a pCAP called dns.pcap. All right. So you can use the tool called tshark to read the DNS packet. So here you can see that we've had a query on greyhat.co, and that greyhat.co resolved to that IP address. It's not true. It's a fake IP address here. So if you want to resolve to a particular IP address, you'll have to set that up. So we'll see later how to do that. But for now, I just want you to see how we could create a simple DNS request and reply on a particular domain and move from there. So we've done this. We've been running pCraft on the DNS AMI with a pcap, and then we run T#. So the pCraft engine has a lot of features, and one of the things that you will need is a proper taxonomy. So you have to name things right, and this name will never change. We have a document called taxonomy.md that you can find on GitHub, and if you have, if you want to force us to use one taxonomy that you guys are using that hasn't been written before, please submit a pull request. I'm more than happy to integrate your new taxonomy here. But in the meantime, those are the names that we are using for the variables in order to set what is what. So the source IP address will be called IP-src in order to just agree on what is the source IP from one plugin to another. So remember, pCraft is plugin based, which means the plugins don't even know what the other plugins know. So the only way to communicate information from AMI to a plugin to another plugin is just to agree on the names that we are using for a particular field that we are interested in. So the DNS example that we've seen before relies on a variable called domain, which is actually part of the taxonomy. So we know that this is a domain name here that can be used then by the DNS connection plugin. Now, if we want to add an IPDST to our DNS transaction, we want to tell, oh yeah, greyhat.co has that IP address here. So I'm just copying this here, and I'm creating the DNS.AMI, and I'm just saying, hey, by the way, the IPDST is equal to this. I can do the same thing. I can recall pCraft and then run T#, and we'll see that this domain resolved to that IP address and not the random local IP address that we've said before. And it's a more realistic scenario. And you can do a few more things. So for example, in our example here, we can even set the resolver, so you can change which resolver is going to be used to get the answer. So in that case, we just want to change towards 8888. And up to now, so the default resolver here is 1111. Why not, right? So if we change that towards 888, we'll see that here, that this is the new resolver that is being used here for that particular scenario. So you can really change everything here as long as you keep the taxonomy intact. So we have a bunch of plugins, and so far you've only seen the DNS connection. So when one plugin is called before the other, in that case we have the plugin called generate new domain. That means sometimes it can take over a variable and make that variable global, so it can be used by the following plugin. So in this case, the generate new domain will generate a realistic new domain, just a domain that does not exist but could be used. So that means we can remove the domain variable. So if I do this, if I change my DNS.AMI and I remove here the domain, you will see that pCraft will fail to work on that file because it's just not the variable does not exist. Well, in that case, my bad, it's been using a default variable. So the default should be example, I think. Nope, it's been using a root. So it didn't fill with anything. So in that case, it's an interesting case. Maybe it's a bug. It's up to you to decide if you think that I should just create an exception here, or just say, hey, I don't have any domain, so I can just have a blank domain, and that will do that kind of funny things. And you likely use the default Scapy way. But I want to generate a new domain, so I'm calling the action generate, which is calling the plugin generate new domain here. And now that I do run pCraft again on that new thing, you will see that it's going to execute first the generate and then the DNS connection. And if I run tshark, you'll see that it's been creating that domain, Scowbite, and that's the domain that it's been using. We can regenerate another domain here. Every time you run, we're gonna have some random domains that are being generated. So it's not a DGA; it's just two words that I'm separating with a dash here, and that can be used to write some domains and pickup that are then used by the DNS plugin. So that's what we do. When we use the generate new domain, because it's creating this domain variable, we can then remove safely that variable from here, from the DNS request action. And then another way that we can create that domain is to increase the scope. So instead of putting the scope inside the action block, we can put it as a global variable, and we can set it here. So we can do that. Let me just open that file. And here I'm gonna create a domain that goes to hellofriends.com, and I can rerun pCraft, and it will create that pcap. So now let's have a look at tshark here, and we can see that we have that domain hellofriends that have been used. So this is a pretty efficient way to just replace and use the same variable across multiple actions here. So we're going to use that later for bigger scenarios where we can say, okay, the victim IP is equal to, and then you can just set the victim IP address here, and then inside your scenario you can reuse that variable. For example, here, if I want to change the IP DST from the victim IP, I can do this right here. So it results to the same IP address, but in that case it was set in the global scope. So the taxonomy plugin is very, very important, because each plugin has their own way of working and their own context. No plugin understands how the other plugin works, so the only way to agree with each other is to have the same taxonomy for the same thing. So you can set a variable using setVar, and you can get a variable using getVar. This is all Python based. And if you want to look at plugin, we'll see that later, but it's in pCraft plugins. And here you have the different plugins. So to get a variable from the context, you just do a getVar. So whether that variable was there from that plugin or created by the other plugin, it doesn't matter. You will just get the variable you should get here. So the plugin that we have now is TCP RST. If you want to send a TCP RST exchange, it's simply a SYN RST ACK and ACK exchange. HTTP connection, which is the one that's creating the different methods for HTTP. You can do a GET, you can do a push, you can do everything you want with HTTP here using that plugin. Generate new domain, which is the one that you've just seen. So this one will just create a valid non-existing domain. DNS connection is to create a DNS query and reply on a particular IP and domain. Ping is just ICMP request and reply. Pickup import is one that I abuse whenever I'm building scenarios. So sometimes I don't have the time to drill down to all the different characteristics of a particular tag, and I want to say, oh yeah, someone has built this pcap, or I built in the lab a pcap about a particular scenario, and I just import that pcap and I change the source IP for what I need to do and need to change. I can say, all right, okay, so here, take that pcap and change the source IP to the victim IP. Another plugin is a hostname from IP, which is generating consistent fake hostname from an IP address. So every time you will find an IP address, you will always have the very same hostname. Fake names is the one that can be useful for creating a fake first name, last name, and email. If you want to create some particular users in your pcap, in your logs. And the last, it's more a proof of concept than a real plugin, but it's working on the DNS and the HTTP protocols for now. I intend to make it better, stronger, and improve it, but you can play with that. You just import a Circana rule, and you will create a pcap that will trigger that rule. So we'll use that later, almost at the end of this workshop. So we can just create a pcap that is made from a Circana rule, and that will trigger something in Circana. So under the hood, pCraft is built using AMI, which is a language that we invented for that purpose. I couldn't find anything that could be useful for me to just describe actions. Everybody's using XML or JSON, or in the PLC world, which I looked at, everybody's using Pascal. So on top of that, so this is a library, this is a C library that then has the C++ bindings, and the intent is to have as many bindings for as many languages that we can have. So on top of the C++ binding, I am automatically generating the Python bindings thanks to pbind 11, which is just awesome. You just tell the classes that you have in documentation, it will generate the Python bindings for you. pCraft is just a user of the AMI Python bindings. pCraft is written in Python. And every plugin from pCraft can be called separately, so you can create a plugin without having to learn everything about pCraft, and it will just be called automatically if you just ask to call that plugin from your AMI file. So yeah, AMI new language. So for those who've been watching and doing my tutorial last summer, for the Red Team Village, I talked about YAML, which was the way I originally wrote pCraft with, where you would just describe your steps in YAML. But I had variables and loops, I had to call functions. I mean, in the end, YAML became a giant mess, and couldn't be sustainable for the next things that I wanted to do. So it's if I look at the action-driven languages, as I was saying earlier, I wasn't happy. I mean, I don't want to use JSON or XML. I mean, this is not meant for a human to be used, really. Like, sure, you can read and have a look at JSON and XML, but this is not great to really understand what's going on. So I just want a simple language to create pCraft actions and make the attack scenario very, very easy to understand. So I can give it to someone, and that someone could say, hey, all right, so you first do that, then you do this, and have a very clear picture of what's going on. So also, this language, similar to the relationship between HTML and CSS, you don't describe exactly how you should write those packets. However, you describe the action. You say, I want to do a DNS connection, and then it will do the DNS connection. But you don't want to say, all right, to do the DNS connection, you're going to do a request and a query request, and then I will get a reply. No. This is not where you do that. You just describe the big picture of what you want, and then pCraft takes over that. And for each action that you want, we'll call the right plugin to do exactly what you need. Then pCraft will really deal with the details. And thanks to Scapy, it's fairly easy to write packets in pCraft using Scapy. So if you are familiar with Scapy, it will be very easy for you to write a plugin from pCraft. So just a quick overview of AMI in 3 slides. You describe the action. So the name here, whatever, is really whatever you want to call it here. It's just a reference name for your action. It's not doing anything here, but it's just for yourself, so you can understand in which step you are. Or, you can use that. And then you have a variable, which in this case is a string, or you can use a verbatim string if you want to use the double quotes inside. And similar to Python, I like that approach where you have those triple quotes that you're very, very unlikely to have unless you're looking for trouble. And in here you can put anything you want. And then you execute the action. So it has to be, in the case of pCraft here, you have to write here the plugin that you want to execute. So this exec is actually something that you need to put right, and by reusing the plugin names that I described earlier in those slides. So if you want to do one action after another, you just write your action one under the other like this. In the second one, I'm just showing you an example of a variable that's being set from a CSV file. So in that case, we just read the file.csv, underline the first line, we get the field called field, and this CSV has a header. And then you call the plugin that you want to execute on that variable. The last part of AMI is the repeat function, where you can repeat in here twice those actions. So you will run that, and the index will be, for the first iteration, will be set to 1, and for the second iteration will be set to 2, which allows you to use that as a variable. As you can see underneath here in the action, another one in the CSV, you have the index that contains the iteration variable, so you can get the first value for the first iteration, and you can set, all right, I'm getting the first line for the first iteration, I'm getting the second line for the second iteration. Also, AMI is built in Python, so you just import PyAMI, and then you can just tell which file that you want to parse. You parse the file, you just get the actions from your AMI context. And then for each action, in here I'm just writing the name of the action and what you want to execute from that action. So it's pretty straightforward. It was really built for the ease of use, and you don't have to think how it works. You don't have to think of the loops. You just know that you have to get the action, and you will get all the actions here. So now it's time to write your very first scenario. All right, so now that we played with pCraft and understood a little bit more about the engine, we're going to create our first scenario. So remember this was the just a simple diagram of the phishing attack that we're going to use as just a simple scenario to understand how to play with pCraft. So the first thing that we do is after setting the AMI version to 1, we create the variables with the victim IP and fake bank IP, which makes it easier later in the script to know what we're talking about here, because we can always call the victim IP as the one that we wanna target. And then what happens in the first step of the phishing scenario is a user clicks on the link. So we have this plugin called generate new domain, which will generate this new domain, and it will substitute this domain variable with that new domain that we've just created. And then the next step is we run this DNS connection from the victim IP as an IP source, and the IP that is going to resolve to that domain will resolve to that fake bank IP. So this way we have a consistent rule of what's going on here. The next step is, after creating a DNS request, we create a post of a form that the user would submit with their login password in clear text. Again, this is just an example here, but in real life this is not how it's going to happen. It's more going to be HTTPS, but still, it's a good example of how we can have the HTTP information encoded into that form, and run that scenario. Now we want to do more than just one. Like the user is gonna try 4 times because they're gonna have a failed logging. So it's not gonna work, and we want to make it more realistic. So we use this repeat mechanism in AMI, where repeat 4 means we're going to repeat 4 times as the index, which is the index variable that's going to be set in case we need it. So in that case, it's going to create 4 post HTTP connections, including, so the HTTP connection will create the regular TCP/IP three-way handshake with the post method. And in that case, the content type is going to be a regular HTML form, when the client content will be this login password. The content length is automatically calculated based on the content, so we don't have to worry about that. A lot of the heavy lifting is is done by pCraft. So let's try. Let's go to the first step. So we define the AMI version and victim IP. So I'm just going to do here a fishme.ami. So in here I'm getting the variable, so victim IP equal to this 55, and then I have the fake bank IP equal to 185.199.108.153. All right. So the variable can actually call another variable. So we could do this new variable here, and we can assign it to the victim IP, which in this case new would be known also as the same value as the one that's being set to the victim IP here. Alright, so let's keep going. Now we generate this new domain. So it's action. We generate a domain, and we just execute the generate new domain plugin. So that's all we do. This will create this domain variable with whatever domain it has generated. So it's just generate the domain, and after that we'll just do the DNS request. So victim IP is the one that's making the DNS request, and it will resolve to the IP DST, which in that case is the fake bank IP, and the domain will be the one from the generating domain, and then we execute the DNS connection. So it's already, the good news about AMI is that we can just try out one step after another to see if it's working. So we can do this, and we can do pCrafter fishme.pcap. And in that case, we should do just a read from T-Shark of the fishme.pcap. And then we're seeing the DNS query here. Oh, that's nice. Englishman commodities. I love it. So it's taking 2 words from the dictionary. So it's random. Sometimes you have some funny name, pretty much like how Docker is doing for naming the containers if you didn't provide a name. So all right. So now we have our first DNS request, and we move on. We have the post data. So it's action post data, and the plugin is going to be HTTP connection, and the method will be a post string. What else do we have? The client content type, and the client contents, which is in that case the login password. So let's copy and paste that. All right. So we're good. Now we have our first HTTP request, and again, I'm just gonna give a try here and do a pCraft of this and run T-Shack on that. So we have our DNS request, then we have our TCP three-way handshake, our SYN ACK, and then we have our data we post. So we can even do this, and we can even look with -x. And here we'll be able to see that we have the login Alfred Wallace that's being pushed to our post request from HTTP. So that's nice. Now we want to do the repeat 4 as index, so we will just simulate a user trying 4 times because it's a fake login page, so it will not get you to your bank account, and gotta do something to the user is just trying again 4 times. So we'll do this. We just add here a repeat 4 as index. Whoops. All right, so let me just do this. All right. Well, I should add an AMI mode for Emacs, so it will be easier to edit in the future. But one thing at a time. Anyway, now we're doing this 4 times. So if I run a pCrafter, it will call the HTTP connection 4 times, and we'll be able to look at this right here. So I don't need the -x. All I need to see is the connection here, so we can see that this particular IP here, that's my victim IP, is making that request to the HTTP server 4 times. So it's like a bigger pcap that can be used. So we've been adding our loop, and now we have our scenario. Basically, if we go back to the original image here, that's what we have here. The victim enters the credentials using the post request, and the rest cannot be seen because it's the attacker that's going to the legitimate bank and get the money out. So the first 3 steps are the things that you will be after, and by doing this pcap, you'll be able to oh, I love the name that it's been generating here. Anyway, with the pcap that you've made right here, it's something that you can replay in your network, and you can actually see the signals of a real, like something that look like a phishing attack on your network. So it will give you some indicators about what to do and how to configure the SIEM. Maybe the SIEM is properly configured, but you want to know, and that's good news. And if it's not the case, you want to be able to catch that and maybe tune a little bit your rules and understand about the thing that you're after. So I'll give you 5 minutes so you can play with this scenario. So let me just do this. I'm just going to show you the entire AMI file so you can have a look at it, and you can just play with different plugins. Remember, the plugins are the ones that I've been showing up earlier, which are whoops, where is it? Here. So don't play with Circata for now. We'll do that in the very end, but you can add a ping if you want. The ping is fairly straightforward, or you can maybe if you have a pcap, you want to do a pcap import, you can do a couple of things here. All right, 4 more minutes. 3 minutes. Two more minutes. So please ask questions from the Discord channel, and please share your scripts or any finding that you have or anything you want to. All right, a few seconds now. All right. Well, thanks. Now let's go to the next section. So this section is about writing a plugin, plugin for pCraft. So first of all, in order to write a plugin, you need to locate where they are. So if you have the Docker image, they can be installed in a default repo, or you can actually go straight to the pCraft directory where I am here in the home builder, and you can go to pCraft plugins, and you can have a look at the different plugins here. For example, TCP RST lives here. So there is some documentation for the plugin. There is a run, which is the core function that's being called anytime you want to run something, which take into parameter the AMI in action, and then it will get the various variables. So all the plugins are in pCraft plugins. If you look at the GitHub repo, and you can really play a lot with them. So also, if you want to locate where your plugins are, you can call pCrafter with something that does not exist. For example, bin ls-foo. You will have a trace of the error, and maybe from here you can actually look at the plugin that you tried to call and didn't call it. So those plugins must be dropped in this plugin directory, and it will be loaded automatically at the startup time with pCraft. So before we really look at a plugin, let's have a look at the plugin structure first. In this case, I mean, with all the plugins, it's the same thing. We have a plugins context. So the plugins context is just a helper function to basically get the variables and let's say it's helpful for you to get the variables, but also other things you may need for all the plugins. So anytime there's something that's coming across other plugins, it will be in plugins context. This way you don't have to rewrite the same thing over and over again. Every plugin have a name, so the class must be pCraft plugin because that's how it's being called. pCraft is looking at all the different files into this plugin directory and is loading all the pCraft plugin class, which inherit from this plugins context. The name of your plugin is it's the action that you're gonna call. So anytime you run exec in this very specific case here, if you have this plugin, you can only create that plugin if you call that my own stuff. So let's do it. Let's copy and paste that plugin here and create play.py. Oh, it doesn't want to copy and paste. Let's see. Can I do this? All right. I'll just copy and paste one line by line. All right, doesn't want to do it. Fine. pCraft plugins context, and then name crawl playground. Next we do our init, and the init takes the app session plugins data. So we'll understand more about the session later. Basically, Scapy is doing a per packet mangling, and we want to be able to do a session mangling instead. So the session is just a helper for Scapy to remember the sequence and act numbers. All right, so we have here the app session plugins data. Now we can do def run. Oops. Come back here. Oh yeah, forgot to close the parentheses here. Run self mi action. Okay. And I just print something. All right, hello from my own playground, and I return the plugins data, which is all the variables, and also anytime you write a portion of a pcap, it's going to be added to this structure. So this is just a helper structure to store all the data about the pcap, but also all the different variables. So now if I call the playground from AMI, it will just write down, it won't even write a pcap, it will just write down hello from my own playground. So let's do it. So I'm just saying Emacs playground.ami. And I do this execution of playground, and that should be it. pcrafter playground.pcap. It didn't say it. Oh yeah, maybe that's because of the name. That should be the file name, so my bad. Right, so we have a hello from my own playground. So I was telling you earlier that this is the name of the plugin that's being called, but that's not the case. This is a file name. So because I call this plugin play.py, I have to call it play from my AMI file. So when I execute play, it will actually call that file. So let me just call this playground so it's easier to understand and we don't mix it up. If I call this, and of course the pcap is just this empty pcap with regular headers from Scapy. So if I do a t-shark of this pcap, it's an empty one. We just wrote down hello from my playground. And back to the things we were doing earlier, I can call that 4 times if I want. Repeat 4 as index, and then it will just write 4 times hello from playground. That's it. All right. So now we need to understand how to write the pcap. So just back to what I was telling you earlier. Just a quick recap. First of all, we get the plugins context, which is all about the plugins. Then I have a name, and we call that name for this plugin. That's how we can make the difference with it. The initialization must call that super function that's going to use the plugins context class. So we can then get the variables, and you just return, oh sorry, that's my spelling here. It's not a return non-self plugins data, it's just a return self plugins data. In order to pass variables, we can print a specific variable here. So I can say, all right, print the getVar domain, or I can even set my own variable here. So let's do it because we already inherited from that. I can look at pCraft plugins play, and here I can say domain var is, and I'll do a self.getVar, and I'll just write domain here. I just want to get the domain variable. So let's call it without doing anything, and let's see the thing that's working. So here, the domain is set to none because we didn't set any domain. So now I'm calling playground.ami, and I'm just writing down domain equal hey. So now we should see var is hey. All right. So that's what we did. Or we can do what we did before. We don't do it here. We just do a new domain for every of our iteration. So we just do an action gen domain, which we'll call the generate new domain plugin. So generate new domain. So every time we generate a new domain. So now we can do a print of this, all those domains that we have generated. Pretty simple, right? We haven't written pcap yet. It's just we wrote something. It was just like a hello world for writing a plugin for pCraft. So now we want to do some packet manipulation. So truth is, we are writing a pcap. So we craft the packet using Scapy, which is a great tool that allows us to craft packets without having to know all the details. Scapy does a lot of default variables as well, the same spirit that we have, and it's easy to use and very flexible. And we create an array that's in this plugins data variable, and we just append that packet to the array, which will then be used to write the whole pcap. So we import Scapy in our plugin. So from Scapy.all import star, we just want to get everything. So in that case, if we want to create an ICMP packet the Scapy way, our echo request will be calling the Ethernet layer and then IP with the variable coming from IP src, and then the destination is the individual IP, and we add the layer of ICMP type echo request, and we append the packet to global array. So that's how we do it. We just call this self plugins data pcap append, and our frame here. So for example, to write a packet with ICMP, the echo request, we just talked about it, and the reply is the same thing, except we invert the source IP as a destination this time, because it's the reply, and we get that individual IP that we've been getting earlier, and we create this ICMP protocol with a type echo reply when we reply to that request. So we can see it here. If I look at pCraft plugins ping, this is exactly what we have. So remember, we have this initialization, and then we get the IP destination. We have a few tricks because we want to be able to do some sweep and do some ping from 0 to 255. But outside of that, we just call the SCAPI packet manipulation for our echo request. We just append that pcap here, and then we have the echo reply, and we append that to the global pcap, and we return that plugin's data. If you want to look at the next one, which is the DNS, it's something. DNS has a query and DNS has a response. So instead of looking at the slide here, let's have a look at the source code. So we check the DNS connection plugin, and we create a bunch of random client IP just in case we're not given one, and something for the server. So remember, in one of the first slides, we've been resolving this gray hat domain, and we were looking for the IP address that for what it would resolve to, and that was like a local IP address. That's just because we take a local IP address for the random server IP, which should be replaced by the IP DST. And if we don't have an IP DST, well, then we get that random value. The resolver is something. The resolver is the one that's 1 and 1 and 1. So there's only one variable that's mandatory here, is the domain. So we craft our query using the SCAPI layer, so Ethernet IP from the IP source towards the resolver, and then we add the UDP layer from this port, which is just a random port I took. Maybe one improvement could be a variable here, and just even set the source port variable as something that we have or default. I'm pretty sure this is what you should do. So please feel free to submit a pull request on this. This is an easy one, and it would actually help you to get your hands dirty on pCraft and start to learn the tool. So after the UDP transport, we add the DNS application layer, where we give the query and the domain variable that we're extracting. So it's kind of magic, because any plugin can add their own domain variable, or the action itself just set a variable, and we can just use that as well. When we have done that, we add that packet to the global pcap that we're going to write out, and that's how we do it. And then after the query, we have a response. I mean, we should have. Maybe we could add more parameters, like the response is incorrect, or domain not found, or things like that. For now, we always find a domain, and we always replace with those default variables. So the source port is always going to be 53, destination port, the one that we've set up here. We just inverse the source and destination, like it's a reply from that server. And then we add the information about the DNS protocol with the recursivity, and we just said the data is the IP destination that we've been setting. So this way, it's a proper DNS request and reply that are added to our pcap. It's as simple as that. It's nothing more here. DNS is pretty simple. SCAPI speak DNS, so we don't have to do anything here. So TCP requires a little bit more work than DNS, because first of all, there's a three-way handshake, and also we must keep the session flow consistent. So if we don't do that, we're going to have invalid packets in Wireshark. because TCP has a sequence of packets and then the acknowledgement on that sequence. So we have to be very careful here. And by default, SCAPI doesn't do any of that. SCAPI doesn't do the consistent session flow. It wasn't meant for that, and that's okay. I mean, that means we just do it ourselves. And we have a util library that help us to write the handshake for us, and a session helper to help us to write the proper sequence and acknowledgement number. So for example, here we want to add the three-way handshake, so we just import the utils library, and the utils library would just say, hey, please, can you add this three-way handshake using the session and the plugins data, and we want to get the source port variable because we use that source port to do this. So the utils is actually part of the plugins. It's not a plugins you can call because it's prefixed with underscore, so that means it's a private helper for the plugin. But you can get things like random IP here, the three-way handshake. So something SCAPI is always going to be SCAPI, so that means we do the scene, SCENAC, and ACK according to the parameters that we have, and then we just add that information to the pcap. Or we can do a reverse TCP handshake. It could be useful sometimes, and something we just use the regular SCAPI feature. For example, if we look at the HTTP connection, which is more advanced than the DNS, not only HTTP gets more stuff, so we can set all those variables like the client headers, the client content, and even the response. Like we can fix what kind of response those servers gonna deliver. We do this, and we add the three-way handshake from that utilities, because we know that all the plugins that are TCP will require the three-way handshake anyway before doing anything. So that's why it's part of the utils. Maybe tomorrow I should move that to the plugins context. Why not? I mean, it doesn't matter as long as you have an example to follow and you know what to do, and it's working. We'll see if I can do a better job of where is the best place to do this. And then according to the variables that we're getting, we're sending an HTTP string, and that HTTP string is really coming from all the things we can set in the AMI scenario. So we have the time. The time comes from the packet that we are creating at the time of now. So basically, pcap has this notion of time on each packet, has the time within the packet, and then you can just use that to write the proper time at which that pickup was generated, because it's about the same time than the one that you've been creating, because I'm getting here the actual time in GM time, and I'm just formatting this properly with what HTTP is looking at here. And then we have the HTTP response string, so it is just the default response content that I have, or you can actually set the variables for everything. So the first HTTP request will be like this, and then we append that request to the session because it's part of the TCP/IP tracking on this. So I'm also using a great library that comes from Bro. So if I look here at the sessionizer, I'm using community ID. So community ID is the CID that I'm getting. So for example here, I'm getting a flow ID based on the source IP, destination IP, source port, and destination port. So this way I know I am part of the very same sequence. And then I'm just adding to the sequence number the length of my TCP payload. And I also check if I'm greater than the maximum of what TCP can get, I go back to 0. So that's quite simple, and is very, very efficient. So then I have a second HTTP request that's actually my response from the server. and I can just append that. I would fix the sequence and act number to just move it using the new session parameters, and I write those data to the new to the pcap to write out. So just to give you a quick overview on how I use the session here, I create my packet using the scapit layers, and then I just append the packet to the session, and then the packet is rebuilt using the new sequence and act coming from the session. So instead of using the one that Scapy is giving us, which is always going to be the same stuff, because Scapy doesn't have this session overview but has this per packet overview. So we rewrite this packet based on what the session is giving us, and then we can append the data to the real pcap. So for example here, from the HTTP connection plugin, this is how we do a post request. So we have some default headers. Of course, we can rewrite the entire header if we want to. There's another option for that, but you would just write the method, the URI, the user agent, the domain, and if we don't do that, that's okay. We have a default user agent, we have a default URI, we have a default method and everything. And then content type and content. The content length comes from just getting the length of the content, so we don't have to write that anywhere. It will be automatically written. So the first request and the session here, as we've seen, and then we fix that sequence and act number, and we do the second request, and we write that second request to our overall pcap. All right, so now we're done with this part, and we're gonna start talking about advanced scenarios. Last but not least, we're gonna talk about the advanced scenario. Advanced scenario is just using some advanced feature from the AMI language. So in this case, we have an action called the collection, where we use the my favorite plugin, pcap import. You're only going always to craft your pcap from scratch. Sometimes you have a lab and you've been creating that pcap based on some data and maybe some protocols that are not supported by Scapy or anything else. So instead of having to write new protocols to Scapy, because it can be complicated and quite a lot of work, you may just have this pcap that you want to reuse in the record, and we'll use the file name and we'll open that pcap and replace the variables. So what we do here is we have a special keyword called field, and the field needs the field name that we want to replace things to. So for example here we want to replace every IP address from what's on the left towards what's on the right. So we're going to replace this 192.168.0.55 towards 10.0.43 and 2. And the same thing with the other one. So let's have a look at this. So first of all, we need a pcap, and good news is we've been generating pcap since the beginning of this tutorial. So I remember there was this dns.pcap. Okay, so we have here the 888 IP address and this one. So let's say I want to replace that. So now what I'm gonna do is replace .ami. And I just call this action pcap replace exec pcap import. I think that's how it's been called. Yeah, and I have file name equal dns.pcap, and we'll do a field at p.replace. So I'm going to replace 8888 towards let's say 1 2 3 4. Okay, so every time we see this 888, we replace with 1 2 3 4. So let's call that pCraft replace.ami replace.pcap. and now I can just do a T-shark -r replace.pcap, and I should have the very same DNS here, except the 888 IP has been replaced with 1234, as we've seen here. So it's pretty convenient because when you do this, you can say, hey, I gave up here. I didn't know how to create that tax scenario from scratch, but I know someone has. I know someone has created a pcap about that particular thing. I just want to add more things around it. So sometimes you want to add more, maybe more DNS requests or more things that are happening, and you just rewrite the source IP with the new source IP and something like you just change all the different IPs that you want to replace using that replace function. It's very convenient. You can just embed something that exists already, or even your own pcap that you've created in the past using pCraft, so you don't have to redo the entire thing. And that's why I chose pcap as a way to glue this and create those network attacks using pcap, so I can do my testing, because there's all those tools that work with pcap already, and there's also all those people that wrote their own pcap. So it's a great format, to be honest. It works well. So now we want to do a very advanced plugin called Circular Rule. So we add to pCraft this thing here, and it will reuse the variables, and it will create all the things that we want. So let's do this. Let me copy this suritest.ami. Oops, I gotta reformat. Okay. AMI version 2.1. Play with Suricata. I just execute the Suricata. I just write all those variables. And I have a rule, and this is my rule with the verbatim here. So it will add a new line here because we've been adding a new line, and it's calling that Circular plugin to create this. So now I can just do a pCraft on suritest.pcap, and I can do T-shark -r suritest.pcap. And we can see that here we are creating our HTTP connection using Suricata. So the last thing is we have this function called CSV that's built in AMI. So we can create a CSV with all those different domains, and we can run this and read all the data that we want to read. So for example, here I have a from csv.csv. Let me just reformat quickly. So we've been generating the domain, the domain name here, and this is automatically done from that IP address. So this way, this IP address will always be mapped to this domain. So it's useful sometimes when you want to have, when you have like a Windows machine and you want to write down some Windows logs in the pcap, and you want to make sure the Windows machine always has the same host name and you cannot guess it, yet you want to run a scenario against that, and you can have this machine automatically generated from the IP. So this way, when that IP will show up later in the scenario, you will have the consistent domain. Or another way to do that is to write the CSV that will map both the IP source and the domain. So I'm just going to call that testcsv.ami. and then I will do a repeat to as index, and I call this action post. I will create a domain that comes from the domain field from my CSV. So the index will be taken from this, so we'll have the two first lines. So the two first lines in this case will be coming from that index. So we are getting this from CSV. So let me say the domain comes from reading the CSV from CSV.csv. The line I'm reading this is coming from the index, so maybe if I want to show them all, I can do a repeat for here. And then I just need to tell the field is the domain, has header equal true, okay. And I run the action post data. And I will just get the post data using a DNS connection, and the DNS connection will be using that domain. As simple as that. So we repeat 4 times as index. We get that value from the CSV using the index becoming the line number, and then we run the action and post data using the DNS connection plugin. Test CSV.pcap. Now I can read that test CSV.pcap, and we'll have the different domains. Oh, we did an increment here. What happened? Index from CSV. Yeah, no, this should be different. Okay, I believe I have a bug here. Let's see if I can get that from here. Okay, so from here, from running this into the action, I was able to get the different domains here. And from the repeat, it wasn't, so I gotta double check what's wrong. Normally it should have been correct, but AMI is a new language, so there's been some, bear with me, it's pretty young. And we just have this domain that we need to put under action here. All right, so the last part of this tutorial is to create your own attacks, basically using this. This is the last part of this presentation is how you can now create your attacks that you are comfortable with AMI, pCraft, and you've seen the capabilities that we've had. So to create your attack, if you've built a plugin or a scenario, please create a pull request issue on this GitHub address, so I can add them to the repository, and then everybody would benefit from your work. So that'd be very beneficial. And also myself, I am learning how to improve the AMI language to make it better and how to make pCraft better. So anything that you guys do want or think it would be great for you, please create an issue. If there's something that's not clear, that I haven't documented properly, it's too complicated, it shouldn't be. So maybe I haven't done a good job to just document and explain how this part works. So open issues as many as you want. This way you'll be able to contribute to the project substantially. So one scenario that I think would be great to write is this vulnerability that was found last summer from the security research at Checkpoint on people using the null bug in the Windows DNS server. So that old bug, when you look at the pcap, is showing that there's this malformed DNS request, and this actually when you do a DNS request, a long request using TCP and not UDP, which has some boundaries here. Windows DNS server is became exploitable. So it'd be interesting to create this kind of scenario of the attack of someone trying to exploit that vulnerability using pCraft. So I'll give you just 5 minutes of your time. So if you want to look around and see how it can be done, and then we'll continue with the presentation. Of course, there's many other vulnerabilities, so feel free to take anyone that you like. So giving you 2 more minutes. All right, good. So let's move on now. Um, and again, I repeat, please create a pull request and share your ideas and scenarios. The last part of this workshop is about playing with a tool called TCP Replay in Suricata. So we're going to create here a rule called my DNS role, and then we're going to load that role using Circata. So I'm just going to alert on the DNS protocol on anything towards anything, and I'm going to write the message DNS query gray hat, just so we know that we're talking about that, and then DNS query. I think now we can do with the latest version of Circata dot, but I've been testing with the underscore, so let's keep that. And we have the gray hat content. So anytime we have a DNS query that contains gray hat, we're going to write that alert. We don't check for the case, and the SID is 2020 10 20th revision 1. All right, that's it. We have our rule. Simple rule. Just give this alert when we see gray hat as part of the content. So I can now just say, hey, Circata minus uppercase S, and call my rule. All right. Now I do docker exec on pCraft. I just go to a new instance of my container, and I want to be able to test this. So I'm going to create a pCraft scenario. So my bad, I'm sorry here. In this slide, I left the old YAML way of doing, but that's fine. At least you can see how I was doing it before, and now we're just going to do it with the new way. So I'm calling that new suricata.ami, and I call that trigger suricata. I exec the plugin suricata. IP source equals to and IP destination will be this one. And the rule will be the one that we just made. So the rule equal, and I'm using here the verbatim quotes. So the rule is going to be alert on DNS gray hat, content gray hat, and that's it. That's the rule I'm calling. Let's see now if I run pCraft on new Circata new.pcap. I have a new.pcap that I can then use. Oops, minus R. So it's just doing a query on a domain called gray hat because that's the one that's in the alert from Circata. So that should trigger the Circata rule here. So I can do a TCP replay of Circata.pcap. TCP replay, hold on. I should do it as root. TCP replay on my interface new.pcap. Alright, this is what it's been playing, and now I'm looking at the log from Circata, and I should have had that's the demo effect here. This is what I should get. Maybe I missed something here in the configuration from Circata, but basically when I've been doing the test in lab, I was able to trigger that log, and if you look at the Circata fast.log, you would get the DNS query alert coming from the alert that we've just made here. Maybe there's a problem with my interface. Let me see. No. Maybe that's where it's coming. Site. Oops, I made an error in my role. Actually, max DNS, my DNS role. Towards any query content. Oh yeah, site. Nope. SID. So let's run that again. Okay. So that's fine. And if I do the TCP replay, all right. So I'm getting it. Finally, good. So you could see that here I was able to generate a log from Suricata using pCraft to generate the pcap. So it's pretty powerful even for Suricata, because that means that we can test the Suricata rules from a unit of that pcap that we're generating. So it's a good way of testing. We just create the pcap from a Suricata rule, as well as we want to trigger some things that are coming from the IDS, and we want to make sure that the IDS is working. So there's nothing better than just writing the rule here and have a look at suritest.ami. That was one that we've made, and the other one, new suricata, sorry, new suricata. That's the last one where we just give the DNS content here in order to create the pcap that suricata is expecting to trigger on. So I'm dancing, yeah. All right, so thank you very much for this workshop. I'm glad you attended. So please, let's keep the talk live on Discourse. I'm more than welcoming contributions, so go ahead. You can reach out to me either using Twitter or via my email. And if you have any more question, you know, reach out to me and let's keep the discussion live. Thank you very much.